To my thoughts. Today we will be dealing with Lacey's method. Before going to the method, if you're new to my channel, you can subscribe below in the below button. So let's go to the Lacey's method. In Lacey's method, we have different steps and it includes 7 steps. And the first step is to calculate the silt factor. The silt factor F is equal to 1.76 into root of mr. And if we calculate the silt factor, we can find the velocity from the formula uf square divided by 140 all raised to 1 by 6. If we calculated the velocity, we can calculate the from continuity equation Q is equal to AV. So we will get the discharge. And after getting the discharge, we can calculate the perimeter P is equal to 4.75 into root Q. We already know the Q value. And in step 5, we need to find the width and depth. We can either use area is equal to BD plus D squared by 2, in which both are unknown, or we can use P is equal to B plus D into root 5, or we can use instead of this the direct formula for D and B as this, and this is most commonly used. Okay, then we can go to step 6, that is R is equal to 5 by 2 into V squared by F, and this is hydraulic medium. We can find it by this two formula can be used. But this step can also be taken as a check step, because if the two value, if we have calculated everything, then in this formula, if we substituted this value and this value should be equal, then we know that what we have calculated is accurate. In step 7, we will find the slope, that is S is equal to F raised to 5 by 3 into 3340 Q raised to 1 by 6. We know the F as silt factor, we know, and we know the Q. So we can calculate the slope. This is the general procedure, and this 7 step are the procedure for that. And now we can move to a problem so that you can understand more clearly. A problem is given that a channel has designed for the following data, that is discharge is given as 30 Qmax, silt factor is given, and side slope is given. So instead of silt factor is given, we can directly go to the step 2, that is we can find the velocity. V is equal to Qf squared divided by 140 into all raised to 6. Here we know that discharge is given as 30 Qmax, so 30 into silt factor is given as here 1. So that 1 square divided by 140 into all raised to 1 by 6. So we will get the velocity. As we know the velocity, we can by continuity equation, we know that area is equal to Q by V. Area, then we can calculate perimeter. So perimeter is given by the equation P is equal to 4.75 into root Q. We know the Q 30, so while substituting we will get the perimeter. So by knowing the perimeter, we can calculate the breadth as well as depth. By simply substituting in the equation, we will get, and you can do it and check the answer. If you have any correction, you can contact me or mail me. So we can next go for check. So check, we know that we have two this one R equal to 5 by 2 into V square by F, that we know the V as well as the silt factor. By substituting, we will get 1.49. And in next, this is a check step. So I have already said that the both value of mean depth should be equal. Here we got both as same, so it is what we have done up to here is correct. Then we go for slope. S is equal to 5 F 5 by 3 3340 Q raised to 1 by 6. By just substituting it, we get this answer, and 1 by this we will get that slope. And so this is how we are going to do it, and the simple procedure. If you have any doubt, you can contact me, and stay tuned for further video, and please subscribe. Thank you.